like to show you what a typical concrete failure test data sheet would look like. Of course, this would also be graphed and made really pretty into a nice chart and all that kind of stuff. But basically, uh, you have a number of different samples. You never just take one. You want a lot of samples. There are errors that can be made when you're doing the samples, and concrete is pretty what they call homogeneous or even, but not always. So you want to make sure that you've got a good number of tests. And in this case, we're doing square tests. It's 1.6 inches by 1.6 inches. Okay, so that's the size of the square. And I didn't measure the length. And then we measure the load. So these are measurements. These were all taken off of one long piece of concrete that we chopped up. So they were all really close to the same. And then the failure load is done with a compression tester. In our case, we used an Interpack hydraulic ram that measures the load, pounds, and it broke when we put 4,970 pounds on it, 4,945, and so on and so forth. Now, these, I'm making up the data. I did put in a high and a low in this range from what the data actually was on our test. And then I rounded it up to the nearest 5. Okay, so whatever the value was, I went up to the nearest 5. So that's how I got these numbers for you. Okay, so that's failure load. So that's the size. And of course, this is the size that I'm pushing on. So I'm pushing on an area of 2.56, length times width. Okay, and my failure stress is pounds per square inch. Per means divide by. So pounds per square inch. And again, I did this little roundup thing to the nearest 5. So that's what this data is. So I'm going to put my name on here. And you'll see all the data changes immediately. And I get some things down here. Now you can actually, if you'd like, you can highlight these now if you'd like to show what those are. But the mean, often called the average, the mean says that I add all these up and divide by how many they are. It's sort of like, okay, yeah, I'm in that range. Mean. Okay, and so that comes out as 2006. But sometimes people want to know, what's my middle value? What value is right in the middle of all these? Okay, and that's hard to tell because these aren't in order. But Google spreadsheet does that for me. So the middle value, right smack dab in between the high and the low, is the median. Okay. It's actually the same number of values are above it as are below it. So if I took 215, I'd find the same number of values that are above it and the same number of values that are below it. And when these are close to each other, we think we have a pretty good test. And then we have a max and a min. And if those are somewhat close to our mean, again, we think we have a pretty good test. All right, and so the engineer would look at these values and decide whether the test was acceptable, met the criteria for the design that the structural or architectural engineer had put forward. So again, mean, that's the average that we know. Add those all up and divide by how many there are. Median is the number so that the same number of values are above as are below. Normally, you'd have to sort this and put it into a sorted range, but we don't have to do that when we have a spreadsheet. The max is the highest value, and the min is the lowest value. And when we get these 3 values somewhat near this value of the mean, we think we have a good test. And the engineer or the architect would look at these numbers and make that determination. So there we go. That's what you do with this. And then when you're done, I'll ask you to download as a PDF and put that onto Canvas.